Yeah. Welcome to the lecture on electrical circuit analysis. So, today lecture is on natural response of RC circuit. Okay. So, let us determine the natural response of an RC circuit. So, coming to the learning objectives of this today lecture is to determine the natural response of a given RC circuit and also to define the what is the time constant of this RC circuit. Okay. So, natural response of an RL circuit. So, this is the given RL circuit, sorry, this is the given RC circuit. So, we have to now see the switch here. So, switch is opening at t equal to 0, switch is opening at t equal to 0. That means, before opening the switch, that is before opening the switch means what we discussed, t equal to 0 minus. So, t equal to 0 minus, we have to assume that the circuit is, the switch is closed and it is connected to the source and the circuit was in a steady state condition. That means, the switch is closed for a long time. So, for t less than 0, that is t equal to 0 minus, the switch is closed. Therefore, 0 minus is used to denote the time just prior to switching, prior to opening, switch opening. So, 0 plus is used to denote the time immediately after switching, that is immediately after opening. So, this is what the condition for the circuit. Now, whenever you any circuit is given, see that switch is opening or closing, that is it. Some problems it is opening, some problems it is closing at t equal to 0. So, t equal to 0 minus means you take opposite, t equal to 0 plus means, so what is happening. So, that is what we are going to do. Now, we have to solve for the just wait, yeah. So, we have to find out the at t equal to 0 switch is open. Now, see for t less than or equal to 0, now because see for t less than or equal to 0, for t less than 0 the switch is closed, okay, the switch is in closed condition only. Whenever the switch is let us say this is point A and point B, okay. So, switch is at A position, okay. Therefore, the energy, the source is supplying the energy to the capacitor, therefore, the capacitor will store the energy in the form of electrostatic field. So, let us say the voltage across this capacitor is, this capacitor store the voltage V of t, okay, V of t is equal to V naught. For t less than or equal to 0, V of t is equal to V naught, capacitor is charged. For t greater than 0, the circuit is, for t greater than 0 means what? Switch is open, switch is open, and switch is open means what? So, this is circuit. And now you have to redraw the circuit, switch is opening here, see here, it is open circuit. Okay. So, whatever the energy stored by the capacitor, so it must be dissipated in the resistor. So, according to the law of conservation of energy, energy can neither be created nor destroyed, but it transfers one form to another form. Therefore, whatever the energy stored by the capacitor, it will transfer to the resistive part. So, resistor will dissipate the energy in the form of heat. Okay. So, now we have to calculate the response. But what we have to calculate? So, we have to calculate the, that is the voltage across the capacitor and current flowing through the current, voltage and current we have to find out, current flowing through the resistor and capacitor. Now, see, so this is circuit. Now, we apply the Kirchhoff current law at this node, okay, at switching action. So, current I is equal to I, sum of the currents leaving the junction is equal to 0. So, I plus, what is the current flowing through the capacitor? IC, IR plus IC, current flowing resistor plus current flowing through capacitor. So, IAC plus IR is equal to 0, this is equation 1. Then, what is the formula for current flowing through the capacitor? So, C into dV by dt, so dV of t by dt. So, that is for this first plus, what is the current flowing through the resistor formula? I is equal to V by R, P of t by R is equal to 0. Now, what we have to calculate? Now, see for the capacitor we have to calculate the voltage first. For inductor we have to calculate the current, for capacitor we have to calculate the voltage. So, we have here dV by dt term. Now, as I want to calculate the V of t, therefore, I am doing some mathematical operations. Okay. So, what is the mathematical operation? You take the C common, okay, and send it to the 0 RHS. So, dV of t by dt plus, so V of t by RC is equal to 0. So, equation number 3. So, you bring this V of t by RC to the RHS side. So, dV of t by dt is equal to the, okay, so V of minus V of t by RC. So, dV of t by dt is equal to the minus 1 by RC into dt. So, only this dV of t by Vt. Okay. So, this is equation 5. Now, how to calculate this integral equations? You know very well. So, variable, separable form, first order equation. So, we can easily calculate differential equations. As I have here integration here, so differentiation here. So, if you integrate on both sides, then integration differentiation will get cancelled, then it is easy to get. See here, integrate both sides of equation 6. So, earlier what you have discussed in the last class. So, the how we determine the natural response of RL circuit. Okay. So, integral of V0 to V of t 1 by x into du is equal to minus 1 by RC into integral of 0 to t dy. This is equation 7. Okay. Therefore, what will you get? So, 1 by x into dx, integral of 1 by x into dx is log x. So, log, that is ln V of t, and you have to apply the limits. What is the upper limit, what is the lower limit? So, lower limit here V0, that is initial voltage, what was there before switching action, and final voltage V of t, initial value, final value. Therefore, you apply the upper limit first and lower limit next. So, log V of t minus log V0. So, log A minus log B is log A by B. So, therefore, log, that is ln V of t by V0 is equal to minus 1 by RC into what is the integral of 1 dt? It is t. Therefore, minus 1 by RC into t, that is minus t by RC, equation 8. So, this equation 8. Okay. So, therefore, V of t is equal to, so V0 into e to the power of minus t by tau, t by RC. Okay. Now, see here. Therefore, what is the V0? Now, I want this V0. I want this V of t. Okay. As this I want this V of t, you please remove the log. Okay. In order to remove the log, you will get a e to the power of. Okay. V of t by V0 is equal to e to the power of minus t by RC. Then you bring this V0 to the RHS side. Therefore, V of t is equal to V0 into e to the power of minus t by RC. So, this V of t. So, what is V0 here? So, already told you. So, V of t is equal to V0. It is initial voltage. So, therefore, substitute here. Okay. So, instead of V of 0. So, V0 into e to the power of minus t by RC. That means, whenever the switch is open, whatever the energy stored by the capacitor, that is the voltage, is approaching to the 0. See, e to the power of minus t by RC. What is this e to the power of means? Exponentially the voltage across the capacitor decreases and it is become to the 0. It is approached to the 0 value. Okay. So, at what rate the voltage became to the 0, that is called time constant of the RC circuit. So, it is also denoted by tau, where tau is equal to RC. So, therefore, V of t is equal to V0 into e to the power of minus t by tau. So, once you obtain the voltage, so it is easy to find out the current. So, what is I is equal to? Therefore, I of t is equal to, okay. So, therefore, I of t is equal to what? V by R according to the Ohm's law. So, V of t by R. Therefore, V0 by R into e to the power of minus t by RC. So, this is the current flowing through the current and voltage response. What is the response means? Voltage we found and current we found. Therefore, this is the natural response. This is the natural response. That means, here natural response means there is no source here. See, here source is there, but it is source is not at all acting upon the circuit, RC circuit. So, this here, see independent source. There is no independent source in the circuit now. So, this response we are calling as a natural response. Okay. So, once you get the current and voltage, then what is the power? P. So, P of t is equal to V of t into I of t, V into R. Or also can say that the power absorbed by the resistor, V square by R. So, therefore, V0 square by, okay, V0 square by R into e to the power of minus 2t by RC. If you substitute the voltage equation, current equation and you multiply that, you will get this V0 square by R into e to the power of minus 2t by RC. Once you obtain the power, then it is easy to obtain the energy stored by the capacitor. So, whatever the energy stored by capacitor, same amount of energy is released to the resistor. So, of CV square. What is the energy stored by the capacitor formula? 1 by 2 into CV square of CV square. Therefore, 1 by 2 into C into what is V? So, V naught square into 1 minus e to the power of 2t by e to the power minus 2t by RC. So, this is what the natural response of the RC circuit. Okay. Now, as I told you, so the voltage across the capacitor decreasing to 0, approaching 0. So, the time constant for the R circuit is equal to the product of the resistance and capacitance. At what rate the capacitor voltage is decreased to 0, that we are calling as a time constant of the RC circuit. So, which is measured in seconds. So, for the R circuit, the time constant is the product of the resistance and capacitance. What about the RL circuit? It is a ratio of inductance by resistance, L by R for the RL circuit and RC for the RC circuit. Okay. So, this is the natural response of an RC circuit and time constant of the RC circuit. Now, if you express the voltage, current, power and energy for the R circuit in the form of time constant. So, this is what? So, V of t is equal to V naught into e to the power of minus t by tau. Next to current I of t is equal to minus V naught by R into, so e to the power of minus t by tau. So, power is equal to V naught square by R into e to the power of minus 2t by tau. Okay. Now, energy is equal to W of t is equal to 1 by 2 C into V naught square into 1 minus e to the power of minus 2t by tau. So, this is the way to find out the time constant of the circuit of the R circuit, and this is natural response of the RC circuit. Okay. So, in this we have to remember for the capacitor RC circuit, we have to remember some points, some important observations. So, capacitor behaves as a open circuit for DC, because what is the current flowing through capacitor? I is equal to C into dV by dt. So, if voltage V is constant, DC means what? Constant. What is the constant of derivative? It is 0. So, I is 0 means what? Open circuit. Now, and also the property of capacitor is capacitor does not allow the sudden changes in the voltages. Capacitor does not allow the sudden changes in the voltages. Now, see here, see, because why? Because this here V of t is equal to V naught here. See, when the switch was closed condition, the capacitor is charging to the V of t, V naught, let us say V naught. But the moment you open the switch, what is the voltage in the capacitor? The voltage is same, V naught only, because it will not allow the sudden change in the voltages. It is a property of the capacitor. Same voltage will continue for a few seconds, for some time. For some time the voltage will continue. Therefore, Vc of 0 plus, that is what you are seeing here. So, therefore, Vc of 0 minus is equal to the Vc of 0 plus. So, that is what here. See, Vc of 0, what is Vc of 0 minus? Vc of 0 plus means after switching action, that means after opening the switch. After opening the switch, what is the voltage? That is equal to the Vc of 0 minus, but that means before opening the switch, that is Vc of 0 minus. Same voltage will be there for the capacitor, because capacitor properties does not allow the sudden change in the voltages. So, this is what the understanding of the today natural response of an RC circuit and the time constant of the RC circuit. So, thank you for listening to the class. We will join in the next class. Thank you.